So now that you've talked about how to find the distance between 2 points, we're going to use that to help us with finding the perimeter of polygons. And we're also going to work on finding area of triangles and rectangles. But notice these problems are on a coordinate plane, so that does change things. So we're going to start with perimeter, okay? So to find the perimeter of a polygon, we're going to first review. Remember, perimeter is the distance around the figure. So you're finding, if you walked around that entire figure, how far would you go? What is the length around the figure? Okay, so that's what perimeter is in general. Now, the other thing to remember is how to find it. So let's review that. So to find the perimeter, to find the distance around it, remember, with any type of figure, to find it, you essentially have to add up all the sides. But remember, to be able to find, or to be able to add up all the sides, you have to know all the sides. So find the length of each side. So find the length of each side. And then you just add up all those lengths. So then you add up all the sides. So find the length, and actually let me put this, find the length of each side so that we get a little bit more specific, and then you add up all the sides. All right, so that's what we're going to do, because notice in these problems, if you kind of look, let's see if I can get this as clear as possible. If you look at these problems, you're not given the lengths. You have to find those, okay? And so that's what we're going to work on, is how can we use what we learned the other day to find the lengths and then eventually find the perimeter, okay? So notice we have to find the perimeter of this figure. Well, if you look at it and any of the sides actually kind of line up with the grid, in other words, you look at the bottom of this triangle, it's exactly lined up with where you can count the length, then count. And remember, when you count the distance or the length, make sure you count the spaces and not the lines, okay? So this one has 1, 2, 3, 4. It takes 4 units. So the length of this side down here, and I'll just put it below it, is 4 units, okay? So that's the length of this side. But notice these you cannot count. Now you're going to want to count because some of them will line up with the diagonal part. But the length of the diagonal of one of these little boxes is not the same as the sides of it, okay? So make sure if the side is at a diagonal, you're going to have to use what you know about the distance formula, or you can use Pythagorean theorem, okay? So what we're going to have to do to find the length of these sides is you're going to either, like I just said, use the distance formula. So like for this side, you're finding the distance between this point and this point. So you would plug those two in the distance formula and do it that way. Or if it's already on a graph for you, using the Pythagorean theorem would actually be easier. So that's what we're going to do. So to find the length of this side, I'm going to use Pythagorean theorem and make a little right triangle with that side and plug it in there, okay? So I'm just going to go to the side, and I'm going to write down, we're finding the length of side from P to Q, okay? So that way I know which one I'm finding, okay? So I'm going to make a little right triangle. And again, you can make it above the line, or you could go below it and make a right triangle too. It'll end up being the same. And then you count. So the length of this side is 2. The length of that side, 1, 2, 3, is 3. And then you plug it in Pythagorean theorem. So those are your legs. Okay, so it would be 2 squared plus 3 squared equals, and then we're looking for that side, which would be our C, okay? So then you simplify. So 2 squared is 4, plus 3 squared is 9, and then that equals C squared. And then 4 plus 9, you get 13, and so that equals C squared. To get rid of the square, because you want to get the C by itself, the opposite of squaring is square rooting, so you square root. So C would be whatever the square root of 13 is. So you could type that in your calculator, and the length of that would end up being 3.61. 1. Okay, so that's the length of this side. All right, so I'm going to go back and I'm going to erase what I did here, and I'm going to put the length that I have. So the length of this side ended up being 3.61 units. All right, so now I'm going to do the same thing here. So for side P, from P to O, I make my right triangle again. And again, you can make it above it or below it, as long as you go from one point to the other. So it's probably easier for me to make it above it. And then I count. So that side has a length of 2. That side, 1, 2, 3, has a length of 3. And notice, these are the exact same numbers that I just worked with. And so it's going to be the same equation. So because it's the exact same equation, I'm going to get the same answer. So I don't even have to do that one again, just for the simple fact that I've already done it. And so I already know the length of this side ends up being 3.61 as well. So 3.61. All right. So now that we've found the length of all my sides, now I just have to add up the sides, because it says what's the perimeter, right? So to find the perimeter, which I'm going to label it the P, all I have to do is add up those sides. And actually, let me write this a little bit below it. So the perimeter equals 3.61 plus 3.61 plus 4. And then I get 11.22. And it's a length. And so you'd put the perimeter would be 11.22 units. All right. So that's how perimeter works. You find the lengths of each side, you add them up, and there's your perimeter. Okay. So let's do a couple more just so you can see a couple more examples, and then you'll have perimeter. All right. So what if we had to find the perimeter of this figure? Well, you have to find the lengths of each side, and then you add them up. Okay, so I'm going to just start with a side. So let's say that I have to find that. Notice it's not lined up where I can count. So that means I have to do my little right triangle. So make sure that you go from one point to the other, and then you find the lengths of each side. So that one has a length of 2. This one, let's see, 1, 2, 3, 4, 5, 6. So that side has a length of 6. And so when I plug it in, it's the side CD. So I'm going to write a little CD. It would be 2 squared plus 6 squared equals C squared. And then I simplify. So that'd be 4 plus 36, which is 40. And that equals C squared. And then you square root both sides. And so that side would have a length of, if I just typed that in, square root of 40, I get 6.32. So that's this side right here. Okay, so I'm going to erase. And I'm going to label that so that I can remember that that was that side, so 6.32. And then I'm going to do the same thing for all the other sides. So to find the length of this side, make my little right triangle. So if I did that, oh, got to make sure that I connect it to that dot. So that side has a length of 1. So we're finding BC. So this side has a length of 1. I'm going to have to write it up here. And then 1, 2, 3 to go from this point to that point. 1, 2, 3. I have to go down 3. So that length is 3. It doesn't matter if you're going up or down. It's the length. So make sure you just put it as positive, or a positive number, and then you put it in your Pythagorean theorem. So 1 squared plus 3 squared equals C squared. Then 1 squared is 1 plus 3 squared is 9. So that'd be 1 plus 9. So you get 10. Okay, and then that equals C squared. Then you square root. So C would equal whatever the square root of 10 is. And so when I type that in, I get 3.16. So that would be the length of this side. All right, so I'm going to go over here, erase, and I'm going to write that down. So I have 3.16. All right, then I got to keep going. So this one, I have to go 2, and then let's see what that is. 1, 2, 3, 4, 5, 6. So 2 and 6. Notice we had already done that. Okay, that was actually what we did down here. So if it's the same equation, save yourself time. That's going to be the same as the 6.32. And then this one, let's see, to go from this point to this point, I have to go 1 and then 1, 2, 3. That's the same thing that we did here. So this one would have the same length as that side. So this ends up being more than likely a rectangle. I'd have to check something else. I'd have to check the angles, but it's looking like it would be a rectangle, okay? So there's my sides. I've got all my sides. So now I just find the perimeter. So add them up. So you got 6.32 plus 3.16 plus 6.32, and I'm just going around the figure, plus 3.16. And when I add those up, the perimeter ends up being 18.96, and it's a length again, so it'd be 18.96 units. All right. So this last one, notice you have all kinds of fun sides. All right. So the first thing that I look for is to see if any of my sides line up with the grid, and unfortunately they don't. So what you would do is you would create your little right triangles all the way around, and you would do Pythagorean theorem for each one, okay? So like for this one, you have 1 and then 1, 2, 3, 4. So for EN, you would take 1 squared plus 4 squared equals C squared. And so for EN, we end up getting 4.12 when we solve. So there's that one, 4.12, and that graph's kind of dark, so it's kind of hard to see. For NT, well, let's see, so I'd have to go that way 2, and then 1, 2, 3, 4, 5, 6, 7. So it'd be 2 squared plus 7 squared equals C squared. And so for that one, I end up getting 7.28 as the length. Okay. Then I'm just going to keep going around. So for AT, let's see, I've got to draw my right triangle. So that's 1, 2, 3. So that'd be 3 squared plus 1, 2, 3, 4 squared equals C squared. And when I solve that one, I end up getting an even 5. So that's nice. So that's 5. So we got 5, and then this one was 7.28. Okay, and then I keep going. So we got 2 more sides. So we got AP. So if I draw my right triangle, that's a pretty big one. It's a big right triangle. And I'm going to count. So let's see. We got 1, 2, 3, 4, 5, 6. So that'd be 6 squared plus 1, 2, 3, 4, 5. 5 squared equals C squared. So then for that one, when I solve, I get 7.81, it looks like. All right, so that's 7.81. And then the last one, so if it has more sides, you do have to do more of the right triangle stuff. We got 1, 2, 3, 4. So that'd be 4 squared plus 1, 2, 3, 4. 4 squared equals C squared. And then for that one, I end up getting 5.66. So from there, so notice this graph was a little bit harder to see. So if it's harder to write your answers down, then you could just write them to the side. Just make sure you don't miss a side. And then you could just add them up that way. So if I add them up, it'd be all of these added up. And so for that one, just making sure that I've typed them all in, I got 29.87 units. So that would be the perimeter of that one.